Welcome back, everyone. It's Ed here. And boy, am I thrilled to have you with us for another exciting exploration into cutting-edge tech. Today, we're tackling machine learning, a field that's honestly changing the world as we speak. And to help guide us through this landscape, I've got the brilliant Cynthia joining me, a true expert in AI. Welcome, Cynthia.
Oh, thanks so much for having me. I'm excited to explore this with you.
All right, Cynthia, before we get into the nuts and bolts, let's set the stage for our listeners. Can you break down machine learning in a way that someone who's never even heard the term could grasp?
Absolutely. Imagine a world where computers can learn from experience, much like we do. That's essentially what machine learning is all about. Instead of relying on explicitly programmed rules, we feed computers massive amounts of data and let them kind of figure out the patterns and relationships that are hidden within.
So we're not talking about hard coding specific instructions, but providing the computer with the tools and data it needs to learn and adapt on its own. What are the essential ingredients that make this learning process possible?
There are three key components we need to consider: data, models, and algorithms. Data is the fuel that powers machine learning. Just like you need high-quality ingredients to bake a delicious cake, you need robust and relevant data for the algorithm to learn effectively. The quality and quantity of your data directly impact the accuracy and effectiveness of your machine learning model.
Data is the raw material, the foundation upon which everything else is built. What about models? What role do they play?
Models are the brains of the operation, if you will, the core where the learning takes place. Imagine a model as a complex network of connections and calculations, constantly being refined and adjusted as it processes data. It's not a static thing. It's a dynamic system that evolves and improves as it learns from the data it's fed. You might have heard of different types of models like neural networks or decision trees or support vector machines. These are all different architectures that can be used to build the learning model, each with its strengths and weaknesses depending on the task at hand.
So the model is like a master chef, taking the raw ingredients of data and transforming them into something truly remarkable. But how does this transformation actually happen? That's where algorithms come in, right?
Exactly. Algorithms are the sets of instructions, the recipes, that guide the model's learning process. They determine how the model analyzes the data, identifies patterns, makes connections, and ultimately learns to perform a specific task. Think of them as the training regimen for our master chef, shaping their skills and expertise. There's a whole range of algorithms out there, each designed for specific types of problems and data.
This is starting to paint a clearer picture. We've got the raw data, the intelligent model, and the training regimen of algorithms. But it's not a one-time setup, and forget it, right? There's this constant feedback loop that drives the learning process.
Absolutely. You've hit the nail on the head. Machine learning is an iterative process. We don't just set up the model and let it run wild. It's a continuous cycle of training, testing, and refining. We rigorously evaluate the model's performance, identify areas where it's making mistakes, and then tweak the algorithms or feed it more data to address those shortcomings. This feedback loop is crucial for the model to continuously learn and improve its accuracy.
So it's like fine-tuning a musical instrument. You keep adjusting and refining until you achieve that perfect harmony.
Yeah.
Now, you mentioned earlier that there are different styles of learning, different approaches that machine learning algorithms can take. Can you tell us more about these diverse learning styles?
Of course. There are four main types of machine learning: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Each approach tackles learning in a unique way, making them suitable for different kinds of problems and data sets. Let's start with supervised learning, which is perhaps the most intuitive. Imagine you're back in school tackling a tough math problem set. You've got your textbook, you've got your formulas, and thankfully, you've got an answer key to guide you. You try a problem, check your answer, and if you're wrong, you can see exactly where you went astray and learn from your mistake. That's the essence of supervised learning.
So in supervised learning, we're giving the algorithm the answer key up front, allowing it to learn from labeled data. It's like having a teacher guiding the learning process every step of the way.
Precisely. We provide the algorithm with a data set where each data point is tagged with the correct output. Think of it like teaching a child to recognize different animals. You show them a picture of a cat and say, "This is a cat," then a picture of a dog and say, "This is a dog." By repeatedly showing them labeled examples, they learn to associate specific features with specific animals. Supervised learning algorithms do the same thing, but on a much larger and more complex scale.
That makes perfect sense. So the algorithm is being supervised as it learns, just like a student being guided by a teacher. But where do we actually see this type of machine learning in action?
Supervised learning is all around us. Think about your email spam filter. It's trained on a massive data set of emails that are labeled as either spam or not spam. By analyzing these labeled examples, the algorithm learns to distinguish between the two, keeping your inbox clean and free of unwanted messages. Or consider those apps that can identify different types of plants just by taking a picture. They've been trained on a data set of images where each image is labeled with the correct plant species. By analyzing the visual patterns in the images, the algorithm learns to identify plants it's never seen before.
Those are great examples. It's amazing how seamlessly supervised learning is integrated into our daily lives. But what about situations where we don't have the luxury of neatly labeled data? Is machine learning still possible?
That's where unsupervised learning steps in. And it's where things get really interesting. Imagine you're a scientist observing a new species in the wild. You don't have any pre-existing knowledge about their behavior or social structure. You have to rely solely on your observations to make inferences and draw conclusions. That's the challenge unsupervised learning algorithms face.
So, no answer keys this time. The algorithm is on its own, tasked with finding structure and meaning in unlabeled data. It's like solving a puzzle without knowing what the final picture is supposed to look like.
Exactly. In unsupervised learning, we give the algorithm a data set and let it explore, discover patterns, and group similar data points together without any explicit guidance. Think of it like giving an archaeologist a box of ancient artifacts. They don't have any historical records to tell them what each artifact is or how it was used. They have to rely on their expertise and the patterns they observe to piece together the story.
That's fascinating. So the algorithm is essentially a data detective uncovering hidden relationships and structures that we might not even be aware of. Where do we see this type of learning being applied in the real world?
One of the most prominent examples is Netflix's recommendations system. It doesn't know your exact taste in movies, but it analyzes your viewing history and groups you with other users who have similar viewing patterns. Based on these clusters, it recommends movies that you're likely to enjoy even if you've never heard of them before.
It's like having a personal movie concierge who knows me better than I know myself. Are there other areas where unsupervised learning is making a difference?
Absolutely. It's widely used in marketing for customer segmentation. Companies can analyze customer data, identify groups of customers with similar purchasing habits or demographics, and then tailor their marketing campaigns to appeal to each specific group. This allows for more personalized and effective marketing strategies.
That makes a lot of sense.
Right.
Instead of using a one-size-fits-all approach, they can target their messages to resonate with specific groups of customers. It's like having a marketing team that can speak the language of each individual customer.
Precisely. Another powerful application of unsupervised learning is in fraud detection. By analyzing financial transactions and looking for unusual patterns, algorithms can help banks and other institutions identify potentially fraudulent activity that might otherwise go unnoticed.
So unsupervised learning is about letting the algorithm loose in the data wilderness and empowering it to discover insights that would be nearly impossible for humans to find on their own. But what happens when we have a bit of both? Some labeled data and a lot of unlabeled data.
That's where semi-supervised learning comes into play. It's a hybrid approach that combines the best of both worlds, leveraging the guidance of labeled data to make sense of the vast unlabeled data landscape.
It sounds like a pragmatic approach, especially when dealing with massive data sets where labeling everything would be a monumental task.
Exactly. Think about a scenario where you're building a system to categorize medical images. You might have a limited number of images that have been expertly labeled by doctors, but you also have a vast archive of unlabeled images. Semi-supervised learning allows you to use the labeled images as a starting point to train the algorithm. The algorithm then uses what it's learned from the labeled data to make educated guesses about the unlabeled images, gradually improving its accuracy as it goes.
It's like having a student who's been given a few solved problems as examples, and then tasked with tackling a whole set of similar problems on their own. They can use the examples as a guide, but they also have to develop their understanding and problem-solving skills to handle the unlabeled problems.
That's a great analogy. Semi-supervised learning is becoming increasingly popular because it offers a practical solution for dealing with the massive amounts of data being generated in today's world. It allows us to leverage the power of machine learning even when we don't have the resources to label every single data point.
It's like having a team of data analysts working tirelessly to make sense of the information deluge. Now, we've talked about supervised, unsupervised, and semi-supervised learning. What about that fourth type of machine learning you mentioned, reinforcement learning? This one always sounds a bit like science fiction to me.
Reinforcement learning is indeed a fascinating and powerful approach. It's inspired by how humans and animals learn through trial and error, constantly interacting with their environment and adjusting their behavior based on the feedback they receive.
It reminds me of training a dog. You reward them for good behavior and discourage them from unwanted actions. Over time, they learn which behaviors lead to positive outcomes and which ones lead to negative outcomes.
That's a great way to put it. In reinforcement learning, we have an agent that interacts with an environment. The agent takes actions, observes the results of those actions, and receives rewards or penalties based on how those actions impact the environment. Through this continuous process of trial, error, and feedback, the agent learns to navigate the environment and achieve its goals. It's like playing a video game where the character learns to overcome obstacles and achieve victory by experimenting with different actions and strategies.
So the agent is essentially learning by doing, much like we do in real life. But where are we seeing reinforcement learning being applied beyond video games?
One of the most impressive examples is AlphaGo, the AI developed by Google DeepMind that defeated the world champion Go player. Go is an incredibly complex game with more possible moves than atoms in the universe. AlphaGo mastered Go by playing millions of games against itself, learning from its wins and losses through reinforcement learning. It was a monumental achievement that showcased the power of this approach to tackle complex problems.
That's incredible. It's mind-boggling to think that an AI could master such a complex game through self-play and trial and error. Are there other real-world applications of reinforcement learning?
Absolutely. Reinforcement learning is being used to develop self-driving cars. The car is the agent, the road and traffic environment is the environment, and safe driving is the goal. The car receives rewards for staying on the road following traffic laws and reaching its destination safely, while it receives penalties for collisions or violations. Through this continuous feedback loop, the car learns to navigate the complexities of the real world and become a safer and more reliable driver.
It sounds like reinforcement learning has the potential to revolutionize industries like transportation, logistics, and even healthcare. It's incredible to see how these algorithms can learn to solve real-world problems through trial and error, just like humans do.
It truly is a remarkable approach, and it's still a relatively young field with immense potential for growth and innovation. As we develop more sophisticated algorithms and gather even more data, the capabilities of reinforcement learning will only continue to expand.
So we've covered the four main types of machine learning: supervised, unsupervised, semi-supervised, and reinforcement learning, each with its unique strengths and applications. What's fascinating is that there's no one-size-fits-all solution when it comes to machine learning.
That's a crucial point. The choice of which approach to use depends entirely on the problem you're trying to solve, the nature of your data, and the desired outcome. It's like choosing the right tool for the job. You wouldn't use a hammer to tighten a screw, would you?
Definitely not. It's about understanding the nuances of each approach and selecting the one that best aligns with the task at hand.
Exactly. It's about having a deep understanding of the problem and the tools available, and then making an informed decision about which tool is best suited for the job.
This has been an incredible journey through the world of machine learning. Cynthia, your insights have been invaluable in helping us understand the complexities and potential of this transformative technology.
The pleasure was all mine. It's always exciting to share my passion for AI and to see the curiosity it sparks in others.
And to our listeners, if this episode has ignited your interest in machine learning, we encourage you to continue exploring. This field is constantly evolving with new discoveries and breakthroughs happening all the time.
There's a wealth of information available: online courses, tutorials, research papers. The key is to stay curious, keep learning, and never stop asking questions.
And if you're looking for a deeper dive into AI and machine learning, we invite you to subscribe to our YouTube channel. We'll be sharing more in-depth content, tutorials, discussions, and interviews with leading experts in the field.
We'll be covering everything from the ethical considerations of AI to the latest advancements in deep learning. So join us on this incredible adventure of exploring the future of technology.
Who knows? Maybe you'll be the one to make the next groundbreaking discovery in machine learning.
The future is brimming with possibilities, and it all starts with a willingness to learn and a desire to understand the power of data, algorithms, and the incredible ability of machines to learn.
Thanks for joining us on this episode, everyone. And until next time, keep exploring, keep innovating, and keep that spark of curiosity burning bright.
Goodbye, everyone, and happy learning.